Recall the power rule when an exponent expression is raised to a power. So if you had an expression and it had a power and then it was raised to a power, then all you had to do was simply multiply the two powers. Now the power property of logs is slightly different. Now it does involve having a power, and what it means is if you have a log that has a power, you're going to move that power out front and it becomes the coefficient of the log. So the log of a number with an exponent is the product of the exponent and the log of the number. Let's do some examples and it'll make sense. So here we have log base 5 of 7 raised to the 4th power. So this log has an exponent of 4, and all we're going to do is simply move that 4 out front and it will become the coefficient of the log. Everything else stays the same. Next we have the natural log or ln of square root of x. Anytime you have a log that contains a radical, you need to rewrite the radical in exponential form. So recall the number underneath is always your base, so it's going to have a base of x and it's going to be raised to a fraction. Since you don't see a number here, it's understood to be a 1, so your numerator is 1 and the root is square root, which is 2. So that will be ln x raised to the 1/2 power. And now that we have it in this form, all we have to do now at this point, because this log has an exponent, we're going to move this exponent out front and it becomes the coefficient of the log. The last example, we have log of x plus 4 squared. So here this is a common log. Notice you don't see a base, so it's understood to be a common log. But regardless, this log has an exponent. So all we're going to do is move that exponent of 2 out front and it becomes the coefficient of the log. And this is the power property of logs.